Good afternoon. Today I'm going to talk about our on-farm research that we did with cover crop interseeding and seeding rates. This is part of a project that myself, Karen Renner, did. Aaron Brooker was a PhD graduate student that ran this project, and he now works for a company in this state as an agronomist. As I mentioned, I'm speaking about on-farm research today with cover crops. And on-farm research would not be possible without our on-farm collaborators. I'm speaking the last week in February of 2020, and tragically this week, Zach passed away following a snowmobile accident. Zach was an awesome collaborator, an awesome MSU Spartan, and our thoughts and prayers are with the family this week. Mark, Blaine, Brooke, and others that collaborated, as I said, our on-farm collaboration makes MSU Ag Research work. And as I said, we're dedicated to the farmer collaborators that help us throughout our work at MSU. So with cover crop interseeding, we have young farmers and old farmers that are awesome innovators and that are seeding cover crops in Michigan. And our goal of many of us is to increase cover crop use in our state. When we think about how Michigan is cropped, about 75% of farmland every year is in corn and soybeans. So our opportunities to add cover crops in a corn-soybean rotation or continuous corn rotation is pretty limited. We can seed cereal rye after corn harvest. We can seed it also after soybean harvest. And we also have opportunities to seed annual rye into corn in the late summer or fall. And then the last bullet on the slide, one other opportunity we do have is to interseed cover crops into standing corn in June. When we think of another way to increase cover crop use in the state, many farmers are seeding cover crops into or after wheat. I bolded the opportunity to frost seed red clover into wheat. This has been a practice in our state for over 50 years. Gives farmers a cover, provides farmers a nitrogen credit. When we seed after wheat, we have farmers seeding all sorts of cover crops after wheat, some species alone, some in mixtures. Our farmers in the thumb often seed certain certain varieties of brassicas. There's about 3 of them that do a very good job in trapping sugar beet cyst nematode. For our non-sugar beet growers, they're seeding many different cover crops after wheat and many different mixtures. About 7% of Michigan's farmland each year is cropped to wheat, so this creates another opportunity to add cover crops. So why growers add cover crops? It just depends on what their motivation is and what their reasoning is. Most growers that are adding cover crops feel it really improves their soil health. They talk about building soil organic matter by adding cover crops, stopping wind and water erosion. Some growers do put in covers to suppress weeds, particularly after wheat harvest. And some growers target the cover crop to add some additional nitrogen to their system. These are all positive benefits of putting in cover crops, and farmers just look at ways to fit them into their cropping system. We know that if we're growing strictly cash crops, that a diverse crop rotation, a very diverse rotation with multiple crops, does improve cash crop productivity. We know we get a yield increase the following year if we're planting a crop different than the crop that was planted the previous year. And farmers, we call this the rotation effect, and farmers do try to beat the rotation effect if they're putting the same crop in each year by adding maybe additional nitrogen, by putting on row cleaners, by adjusting management practices so they don't have as much of a rotation effect. Our interests were if we could put cover crops into a rotation to increase diversity that way, and could we improve crop yield? So that's the long-term goal of looking at adding cover crops to our rotations in Michigan systems. Today, I'm just going to talk about a small part of our research in this overarching goal. So what we did for a few years, we have interseeded cover crops into corn in June. So here you can see corn rows on the left and right of the slide. And then you see in between the corn rows, plants. And as you look at the slide, you go, oh, okay, you know, I see something that looks like a radish. I see something that looks like some type of a grass. And I'm hunting here to see if maybe there's a clover in this picture. So when we interseed cover crops in June into corn, this allows us to seed a single species of a cover, or we can seed multiple species like shown in the slide. So as part of this research project, we looked at on-farm interseeding throughout the state in 2017 and 2018. So our on-farm collaborators seeded annual ryegrass, they seeded tillage radish, they seeded crimson clover, and then they seeded a mixture of these cover crops into their corn at 2 different times. Their locations are shown here with the green circles. The 2 red stars are MSU research farms where we did the same, and then we also kind of expanded that a bit so we could look at some different seeding rates. So what we would do is the grower, our collaborator, would go out and seed these cover crops 2 different times in their fields. These would be long strips of cover crops, the whole length of the field, and then those strips would be replicated. So you wouldn't just have half the field with a cover in it and half without. You'd have strips of annual ryegrass as a cover interseeded, strips of tillage radish, strips of crimson clover, strips of no cover, strips of the mixture going across these on-farm fields. And then after the farmers seeded, myself, Erin Brooker, and the rest of our group in the weed science program at MSU, we would come up, we would look at how many plants emerged, you know, what was shown about 30 days after we seeded. And then we would look at that again during the summer months. We looked at weeds also, what types of weeds were across the state in these fields. And then in the fall, before the grower harvested corn, we would go in there and again look at the density, but we would take the cover crop off of the field in like square yard areas and measure how much cover crop biomass or weight we had there. And also if there were weeds, we would measure that too. So we're doing the biomass usually early October. It's prior to corn harvest. And remember, covers keep growing up until the first killing frost, but this was a time that we had to go in there before they were running the corn. And then we would take corn yield also to see what was going on with that. So we use various types of broadcast interseeders depending on what the collaborator was using. Here's a picture of a couple of them. And the farmers that were doing this were all interested in cover crop interseeding. They had built these interseeders themselves. We put together one on a toolbar that we could use at other locations. And these farmers were all highly interested in soil health and wanting to seed cover crops to protect the soil from wind and water erosion. So the growers would seed at V3, V4 corn, which is shown here, or, well, not or, and they would come in later in other strips and seed the same covers at V5 or V6. Now, how the growers managed weeds in general was they would apply glyphosate at 32 ounces just prior to each interseeding time. Some of the growers had pre-emergence herbicides down at planting, sometimes reduced rates of those. Dr. Christy Sprague also has a video on this that you can watch that gives you details about herbicides in cover crops. So for today, I'm not talking about that. I just wanted to mention to you that when we were interseeding on the growers' farms, or when they had just applied glyphosate to kill any existing weeds before they interseeded. Now, we often get asked what the seeding rates are, and this is what we seeded. And this is pounds per acre on the top line, and then seeds per square yard below that. So we based our seeding rates on what the collaborators felt was realistic and what we should be interseeding. We also looked at the Sustainable Ag Research and Education Program and their recommendations, and also the Midwest Cover Crop Council recommendations. So these numbers were not just pulled out of a hat, but were discussed a lot with everybody before we decided that these should be probably our suggested seeding rates. And if you look at the numbers as seeds per square yard with a visualization, it makes sense to you. You know, when you think about annual ryegrass, it's a lawn type grass. You're seeding a lot of seeds, you know, per square foot or square yard. When you think about the size of an oilseed radish seed, you know, it's pretty large, so you're not seeding that many per square foot or yard. And then your crimson clover seed, as you all know, is about the size of an alfalfa seed, very small, so you're seeding multiple seeds of those per square foot or square yard. So what did we learn from working on the farms? So what this shows you is what happened in 2017, okay? And this is the number of plants per meter squared on the y-axis, which is like plants per square yard, to have a visualization. Clayton, Michigan is down south, okay, almost on the Ohio border. Hillman, Michigan is up north in Presque Isle County. Springport, Michigan is south of East Lansing, about 35-40 minutes. Hickory Corners is just north of Battle Creek, Michigan, and Hart, Michigan is along the west side of the state. So annual ryegrass is shown in the dark green bar, and you can see that annual ryegrass established at all locations in 2017. Hillman and Hickory Corners Site B had really good annual ryegrass establishment. And then the next bar over, the crimson clover, is kind of the middle bar. You can see how many plants were there about 30 days after we interseeded. And then oilseed radish is shown in the far right light green bar. Now, this is plants per square yard, so this makes sense because remember, radish, we're only seeding 18 seeds per square yard. So if you end up with about 18 there, that's a pretty good deal. Remember, annual ryegrass, we were seeding over 200 seeds per square yard. So you would expect to have over 100 plants there 30 days after planting. So this showed you what happened in 2017. In 2018, we had very low rainfall across the state, especially the southern half of the state. And you can see at Springport, where they didn't have rain for almost 40 days after interseeding, we had very poor establishment. Hart, Michigan isn't even shown on the slide. Hart had a severe drought. This was a non-irrigated field in 2018, and they had no way to irrigate the cover crops up or irrigate the corn. And then Hickory Corners was also quite dry. Up north in Hillman, Michigan, they had adequate rains in the summer of 18 during June and early July, and so you see establishment was quite good. So again, a reminder, this is kind of what we're seeding, and you're hoping that every seed comes up and establishes. But what growers are most interested in, and what we're interested in for soil health, is what is the cover crop biomass? What do we get out of the number of plants that are there? Because I can have 5 plants that aren't competing with each other and produce the same amount of biomass as 25 plants that are competing with each other and produce each individually less amount of biomass or weight. So this slide summarizes what cover crop biomass was in the fall. And the pies are in the area of where the farmer cooperator had his fields. So you can see we were up north by Hillman in 2017 and 2018. You can see we were by Hart in 2017, and then the drought didn't let the cover crops establish in 2018. And then how big the pies are is how much cover crop biomass there was. So a big pie means there was a lot of biomass, and a small pie means the biomass was very, very low. So look at 2018, look at the H, and look how small the pie is. That was Springport, Michigan at Hasneck's farm. And you can see Within the pie, oilseed radish was the cover crop that dominated in the dark part of the pie, and then there was a little bit of annual ryegrass shown in the white part of the pie. So the size of the pies is how much biomass there was, and then the colors within the pie tells you how that biomass was distributed, like which crops produce the most biomass. And you can see that sometimes it was annual ryegrass, sometimes oilseed radish. So it varied by location and year as to which cover crops produce the most biomass when interseeded on farm at either V3 or V5 or V6. And we found that both of those establishment times worked fine, and that the best establishment, it didn't matter if it was V3, V4, V5, or V6, it was really dependent on how much rainfall occurred after broadcast interseeding. So why this variability in cover crop fall biomass? Why do we have these differences? On the right here is a picture of corn that's obviously ready to harvest, and this is one of our interseeded locations. If you look down between the rows, you can see the oilseed radish is green and growing. You can see some clover in there also. And as I mentioned earlier, we did biomass at this time, but these cover crops continued to grow until the very first killing frost, where your radish would die because it is winter killed. Your annual ryegrass and your crimson clover would not winter kill, and those would continue to persist into spring of the following year. So one thing we noticed is that we somewhat had differences possibly in the type of ground cover that we were interseeding into. So where farmers had tillage, it appeared that we had somewhat better establishment than where farmers were planting corn no-till and we were interseeding cover crops on top of the ground broadcast into no-till fields. Now this is not a direct study. We did not compare side-by-side cover crop establishment in tilled and no-till fields. This is just something that we looked at as we were thinking about what may be reasons why we have more or less cover crop establishment. So we also noticed that if the corn population was low, under 30,000 per acre, and some of this ground that farmers were working on was sandy ground, many were seeding at 28,000. If we had lower corn populations, that would allow the cover crop biomass to be greater. And that would make sense because you'd have less shading somewhat during the growing season. And then as that corn senesced, you'd have more light coming into that underlaying cover crop system, and you could accumulate more cover crop biomass. So this is a chart that we use in one of the publications that we write for people to read that work in our field. And just wanted to show you, when we looked at it by tilled and not tilled fields, you can compare, like annual ryegrass establishment was 157 plants per square meter 30 days after in our tilled fields, and only 40 in our no-till fields. And you can see that difference with crimson clover at 30 days after interseeding, DAI, and you can also see it at harvest. So the bottom part of it is the biomass, and you can see then again that differed somewhat. So we are certainly not advocates of tilling fields to establish cover crops. That's absolutely not what I wanted to point out. I did want to point out that that soil surface and trying to get cover crop seed soil contact appears to be somewhat more difficult under no-till field situations. And that was the point of this. Definitely not recommending tilling to establish cover crops, but wanting to show farmers in Michigan that if they are in a no-till situation, it appears to be more difficult to establish cover crops when you just broadcast them on the soil surface, and that makes sense. So to summarize our on-farm research, the cover crops established V3, V4, V5, V6. In annual ryegrass usually had the highest initial density, and that makes sense because you're seeding that at the highest number of seeds per square foot. However, oilseed radish, the biomass of that cover crop, was equal to or greater than the biomass of annual ryegrass and crimson clover across all sites in years. The fourth point is key. We know that rainfall after interseeding really improves emergence and cover crop biomass. So if a farmer is thinking about interseeding and they say, when should I interseed? I say, when you know it's going to rain. So whether that's at V3, V4, or V5, or V6, if we can interseed prior to Michigan getting a couple, 3 days of rain, then we have excellent cover crop establishment. I would comment that in 2019, which we were not doing on-farm work, the cover crop establishment at 2 of our research sites at MSU was excellent. The biomass was excellent. So we know that it is very, very much rainfall dependent as to the success of interseeding cover crops in corn if you are broadcast interseeding. And my last point here was that tillage improved establishment. In other words, not having the ground not under no-till. So if there was some form of tillage that the grower was using prior to planting corn, that really helped cover crop establishment if our rainfall was low. But again, we're not advocating that. I am all for the no-till or conservation tillage systems across the state. I just want growers to be aware that it is more difficult to establish cover crops broadcast interseeding if you're running a no-till operation. In closing, I wanted to show you a few pictures of what the biomass looks like in the fall. We take these just prior to corn harvest. Remember that biomass keeps accumulating up until it gets really cold. Crimson clover and annual ryegrass overwinter in Michigan. So these are pictures in early October, and biomass continued to accumulate up until December, and then again it started in the spring. These pictures are from fall 2019, the year that we had a lot of rainfall. This is not on the on-farm collaborators site. This is on one of our MSU research sites. But you can see the biomass of the clover is excellent on the left. In our annual ryegrass, you can see the establishment there. We also looked at if seeding rate makes a difference. We came up with our seeding rates, as I said, through discussion with farmer collaborators and through looking at Midwest Cover Crop Council, our own experience, and came up with our seeding rates. But I always wonder, we ask, if we seeded more seeds per acre, would we get more biomass per acre? And adding more seeds per acre costs more. So we're interested in what is the optimal seeding rate for these cover crops. So this was the seeding rates that we looked at. So 0.5x means it's kind of a half rate, what we consider to be half of what's ideal. 1x would be what we thought of as a standard type seeding rate. These are all in pounds per acre. And then 2x would be a double seeding rate. And we tried a mixture of annual rye and crimson clover, and you can see what the numbers we used for when we seeded the mixture. So did increasing the seeding rate increase plant density? And the answer to that is yes. This is at the East Lansing Agronomy Farm in 2017. And the bigger the bar, the more plants were there. And so it makes sense that you see a stair-step approach. So for annual ryegrass, the half-X rate, we had about 100 plants. The 1X rate, about 150 plants. And the 2X rate, about 250 plants. If you look at crimson clover, you see a similar stair-step approach. The more clover seeds we put out there, the more plants we had there. And oilseed radish, maybe not so much of a response, but remember, we're not seeding that many per acre. If you go back here with radish, we're seeding 6, 11, or 22 plants per acre. So my scale here, you can see the 6 is about 6, the 11 is about 11, and the 22 is about 22. So yeah, we can increase density if we increase the seeding rate. This was at our other location up in Saginaw Valley Research Center north of Frankenmuth, and you can see similar response. So yes, if I increase my seeding rate, I'm going to get more plants there. Again, farmers want plants there, but they're most interested in density. This is MSU site in 2018. And here is, again, the stair-step approach that the more I seed, the more plants I have per square yard. So I misspoke earlier that farmers they want plants there, but they are most interested in biomass. So if I increase my seeding rate, can I increase the biomass? And did that happen? So all our locations are getting more plants. So does that equal more biomass? So this is summarized over all 4 locations years. So we had 2 sites in East Lansing on a Park Hill loam. We had 2 sites up north of Frankenmuth at the Saginaw Valley Research Center on a similar soil textural class, a little bit higher organic matter. So when you look at these, what does it tell you? So you see these gray bars, and what you would like to see is that the half X has 200 pounds, let's say, of biomass. The 1X has 400, and the 2X has 800. So you want to see, again, the same stair-step approach. And if you look at these gray boxes, you can see that that is true, that the 2X gray box is always higher than the 1X gray box or the half X gray box. So we do know by increasing the seeding rate, we do get more biomass. Now, if you look at this slide for a bit, you see these stars that look like black dots above each of the boxes. And what these are maximum amounts of biomass that were produced. The gray boxes are the averages across all 4 site years. The stars show what a single site year, what a maximum amount of biomass was produced. So when I look at those stars and where they are, or the dots, if they look like dots too, above these gray boxes, you can see, if you just look at those, that yes, doubling my seeding rate to 2X gave me more biomass at certain locations, tremendous amount of biomass compared to 1X. But overall, upping seeding rates always increases biomass. It's just a question of seed cost and what the grower is trying to do. We had one site I wanted to comment that oilseed radish produced up to 4,000 kilograms per hectare, which is similar to pounds per acre. And in visiting with our cover crop collaborators, many will talk about that. Remember, we're measuring early October. And the last 3-4 years in Michigan, we have had very warm Octobers and Novembers. So these cover crops continue to accumulate biomass in October and right through November. So these numbers here are not the end game. The numbers keep building after these numbers taken in early October. So here's a picture of the 2X seeding rate of annual ryegrass on your left and the 1X seeding rate of annual ryegrass on the right. So you as a grower can look at that and go, which of these would I like to see in my farm field? And is it worthwhile for me to spend a bit more money to get a 2X and use a 2X seeding rate? Remember, we are broadcast interseeding, and that means the seed is laying on the soil surface, so we don't get all our seeds germinating like you would if you were drilling your cover crops. Here are two pictures of tillage radish, the 2x or twice the seeding rate on the left and the 1x on the right. And here's crimson clover, what it looks like in what I would say a normal year of rainfall. The 2x is on the left and the 1x is on the right. When I showed you the previous slide of crimson clover from 2019, if you recall that year in June and July how much rainfall we got, we had a tremendous amount of rain and excellent cover crop establishment and growth then in the fall also. Our corn grain yield in all the locations, all the years with the farmers at their locations and on our MSU research sites, we had no issues with corn grain yield with these cover crops interseeded. Remember, our biomass in early October is below 1,000 pounds per acre. However, at some sites, we had over 3,000 pounds per acre of biomass of radish in early October. But seeding at V3, V4, V5, V6 into corn, these cover crops did not reduce grain yield compared with the weed-free controls. So in summary, our cover crop density and biomass increased with increased seeding rate, okay? And V3, seeding a couple weeks before V6, did not consistently produce more biomass. And we get around 1,000 pounds of biomass by early October. Tillage radish, we can get quite a bit more than that. And then a reminder to growers that cover crops keep growing in the fall after early October to produce more biomass and continue to provide ground cover, protection from wind and water erosion, etc. We know we need rainfall to get broadcast interseeding to work. That is just critical. We know that cover crops don't reduce corn grain yield when we seed V3 or later. And in our research, cover crops really didn't do a great job suppressing winter annual root weeds. Our grower cooperators would tell us that they'd seen some suppression of winter annuals if they have just a very, very, very thick cover. So our recommendation is drilling cover crops into corn. It's a much slower process, but you will get excellent establishment. If you don't want to drill and want to broadcast interseed, you can go much faster. You are going to rely on rainfall to get those cover crops to establish. You can interseed anytime from V3 through V7. Rainfall after seeding is just critical for establishment. And weed control is very important. Dr. Sprague has another webinar talking about weed control. The middle bullet there about grass seed is important to remember. Grasses are very competitive. So if you are seeding a grass mixture, you want to keep your grass seed at 20–25% or less of the mixture. Also, it would be too competitive and not allow your other species to establish. In closing, USDA funded some of our research. Project Green, the Corn Marketing Program, La Crosse and Center Seeds also provided funding for our research. And lastly, again, I'd like to thank our on-farm collaborators. They are innovators, they are thinkers, they're always willing to share ideas, thoughts, what they've heard, what their farm is showing. And without our on-farm collaborators, MSU research would be not as relevant to our growers in the state. So again, thank you so much to these on-farm collaborators and their families.